Welcome back to topic 38 for Algebra 2, solving logarithmic equations. In part 4, we're going to be doing more example problems, especially involving the inverse properties of logarithms. In our first example, we have 5 plus e to the x plus 1 equals 20. And in all of these examples, we want to solve for x, or solve for a variable. So in order to solve for a variable, we need to eliminate any stragglers that are on that same side. So here we have our 5. We're going to subtract 5 from both sides and end up with e to the x plus 1 equals 15. Now, taking note of our inverse properties of logarithms, we have b to the log base b of x equals x, or log base b of b to the x also equals x, as well as the corresponding properties for natural logarithms, which are the same thing. Here, we have a base of e. So in order to cancel this out, because what we really want to focus on is our exponent of x plus 1, so we can isolate x, what we want to do here is take the ln of both sides. Because ln has a base of e, which we often don't write, but it's there. On the left-hand side, using this property, ln base e of e to the x equals x. So the left-hand side, this will cancel, and we're just going to be left with our exponent, which is x plus 1. Now on the right-hand side, we're still going to be left with ln of 15, because what we do to one side, we have to do the other, which is why we also take the natural log of 15. Now, in order to isolate x, we have one more step to do. We have to subtract 1 from both sides. So we'll end up with x equals -1 plus ln of 15. Now we can plug in the natural log of a number with base e into our calculator. So we're going to transition over to Desmos. So -1 plus ln of 15 equals 1.708 if we want to round to the thousands place. So x equals 1.708. Moving on to the next example, we have 2 times e to the x equals 10. Now instead of subtracting, here we notice that we have multiplication, and the inverse of multiplication is division. So we're going to divide both sides by 2, and we will get e to the x equals 5. Now similar here to example number 1, we're going to use the inverse property in order to get x alone. So we're going to take the ln of both sides. And note, again, that ln has a base of e. So that's why we were able to cancel it using the inverse property. On the left-hand side, we'll just be left with my exponent, which in this case is x. And on the right-hand side, we'll have ln of 5. Now we can plug this in to our calculator. So the ln of 5 is 1.609. So x is approximately 1.609. Moving on to the next example, we have 2 times log base 4 of x equals 5. Now notice here how we're not dealing with natural logs anymore, but instead we're dealing with regular logarithms. But my base here is 4. It's not 10. So we're going to keep that in the back of our mind for a little bit later in the problem. First though, we notice that we have 2 times this. So we're going to divide both sides by 2 so we can eliminate that. So we'll end up with log of base 4 of x equals 5 halves. Now if we go back to our properties, we notice here how we have log base 4 of x equals 5/2. What we're going to use is this top left property, b to the log base b of x equals x. So moving back to example number 3, because my base is 4 here, I'm going to exponentiate both sides, or change to exponential form. And that's because I'm following the inverse property of b to the log base b of x equals x. So whatever my base is, in this case it's 4, that is going to become my base. And my other values from my original equation are going to now become the exponents. So using this property, it says that b to the log base b of x is x. So what I'm just going to be left with on the left-hand side is my exponent. On the right-hand side, I'll be left with 4 to the 5/2. Now, instead of plugging this into your calculator, we can actually do this because we are dealing with rational exponents. So this is equivalent to x equals the square root of 4 raised to the 5th power, because square root has root of 2. So now we can simplify this using PEMDAS. The square root of 4 is 2. So this is 2 to the 5th power, which is the same thing as 32. Moving on to the next example, we have 20 times the ln of 0.2x equals 30. So right off the bat, we notice that we have multiplication here. So we're going to divide both sides by 20. And we're left with ln of 0.2x equals 3/2. Now using the same property that we used in example 3, but this time we're dealing with natural logarithms. So instead, we're going to use e to the ln base e of x equals x. And that's because my base with natural logs is e, or Euler's number. So I'm going to change to exponential form by using my new base of e. So I will get e to the ln base e of 0.2x equals e to the 3/2. On the left-hand side, this will cancel, and I'm just left with 0.2x equals e to the 3/2, or 1.5, whatever floats your boat. Now, I could divide by this 0.2, divide by the decimal, or I can also identify that 0.2, or 2/10, is the same thing as 1/5. So 1/5 x equals e to the 3/2. Now, I can multiply both sides by 5 in order to get rid of my fraction, which is the reciprocal, and I'm left with x equals 5e to the 1.5, or 3/2. So to solve this, I'm going to go back to Desmos to plug this into my calculator. So 5 times e to the 1.5 gets me 22.408, if we round to the nearest thousandths. Moving on to example 5. In example 5, we have log base 3 of 2x minus log base 3 of x minus 3 equals 1. Now again, remember what our instructions are. We're asked to simplify. And simplifying is the same thing as condensing. So we're going to condense the left-hand side. When I'm asked to condense, I want to think back to my properties of logarithms. So here, because I see subtraction, that equates to the quotient property when I'm dealing with my properties of logarithms. So I can rewrite the left-hand side to be log base 3 of 2x divided by x minus 3 equals 1. Now notice here, I have my base of 3. I want to get x alone. So I'm going to be using the inverse property and exponentiate both sides. So my base is going to be 3. The left-hand side cancels, and we're just left with 2x over x minus 3 equals 3 to the first, or just 3. So here we are exponentiating both sides. Or basically changing to exponential form. Now we can simplify it by using the inverse property. That's why it canceled out. Right over here. Now we can simplify. So we can use cross multiplication. It's back again. So we are left with 2x equals 3 times x minus 3. Use my favorite property, which is the distributive property. We get 2x equals 3x minus 9. Now in order to solve for x, I'm going to get all of my terms on one side. I should say all of my like terms on one side. Subtract 3x and get negative x equals negative 9, which can be rewritten as x equals 9. Moving on to our last problem. We have 3 times log of x equals 6. So again, what we're going to do first, you guys know the drill, divide both sides by 3. So we get log of x equals 6 divided by 3, which is 2. Now here, I want to change to exponential form, but what is my base? Well, this is the common log. So if I don't see a base written, my base is automatically 10. So if I'm asked to change to exponential form or to exponentiate both sides, I'm going to use my base. Now my base here is 10. So when I change to exponential form, I'm using my base of 10. This cancels using the inverse property. And I'm left with x equals 10 squared. And 10 squared is the same thing as 100. And that's your answer. Thank you for watching.